Hello. Today what I would like to do is to show you how to access on-screen takeoff using a remote access and then submit your work through the course website.
We will use an example, estimating steel angles. The first step that we want to do is to open a web browser and following the link www.eic.fiu.edu. This link is going to take us directly to the Engineering Information Center web page. We can then click in Engineering Software and follow the log on to access your applications. This is going to bring the Citrix screen in which you need to add your username and your password. After you enter the information and click the log on button, you have to be careful. Look at the screen because there may be some messages that you need to take care of before running the applications. Then go and proceed to open on-screen takeoff. Again, you have to look for messages on the screen to launch the application. Here we have this icon launch ICA, so we have to open that in order to get on-screen takeoff working. Different browsers have different requirements, so make sure that you look at your browser carefully and understand the process to launch on-screen takeoff. After the software is running, then you want to make sure that the folders are correctly labeled. In this case, they are not. And I do have folders list here that I can use to remember how the folders should look like. So all I have to do now is just copy the name of this directory and paste it on screen takeoff. That saves a little bit of time, plus helps you to get the correct numbers every time. So after these folders are correctly set up, click apply and OK to get the on-screen takeoff working with the correct parameters. Then you want to open your database. If you have a bunch of databases over there, you can just click remove to delete the ones that you don't need. And don't worry about it, it will not delete the one that is in the directory that you have set up here. So in my case, in tools folders, I have 4612 database, so it will not let me delete any database that is inside that folder. So I can select everything else and just delete it. Now I can click on my database and open the course project. Okay, as you can see, my software is not licensed. In the right bottom right corner it says no license, so I need to check authorization and enter the values for use floating license, and then the server is license 2. So I click the authorized, I get the authorization, and I'm good to go. So what I would like to do now is to work on a structural. I want to look at the roof framing plan S2, and then go to the structural drawing, and I see that we have here L1. This is the scope of my work today. I'm just going to estimate this L1. Now we may want to see how L1 looks like. We may want to go to this S4 detail 8. So I have a hot link to that page. So we bring it here. This is section 8 in drawing S4. So I can look at this detail, and I will see that there is a deck angle. This is the one that we are estimating. So we see that deck angle goes parallel to this beam, and it's supported by bolts. So it runs the direction of this wall on the outside, so it will support this um, covered patio that we have over here. So I am going to create a new condition. It's going to be a linear condition because I want to measure the length, and I am going to call this L1. In the notes, I can type that L1 is an L 3 by 3 by 1/4. So then I have the information about that L1 in my notes. And I want to run this from the end of the building all the way down to the beginning of the building. Okay, so now I have measured 97 linear feet of L1 on this side. We can see that there is also L1 on this wall. We have L1 and L1, so it seems like it's running both ways. We can look at this detail S410 and see S410 has a angle on the left side, and it has another angle on the right side. So those are the two L1s that we have to account for. They run the whole length of the building. One is to support this structure, the other one is to support this structure. So I am going to go ahead and estimate L1, I'm sorry, from this point on. It looks like it will start down here and goes all the way up to this point, then crosses to this section, then it goes again over here, and that's L1. And on the other side I also have L1, so I'm just going to run this line parallel here, and I know this will be the L1 that goes to the right of the first L1 that I have. So again, if we go back to this detail, one of the L1s is this one here, the other one is this one up here. Okay, so it looks like I have measured in this drawing 264 linear feet of this angle. Now I can go to my Excel file and open the OST data tab that I have to import information from on-screen takeoff. Go to the takeoff tab and then just copy the L1 that I have created here. Take that information, copy, and then paste that in my Excel file. So now I have here the takeoff for these metals, this L 3 by 3 by 1/4. I have 264 linear feet, and now I am ready to start calculating the cost. To calculate the cost, I am going to use the software WinNest. So WinNest will allow me to add a item. I'm going to add a steel uh, metal fastening welding. I want to add a angle, so I'm going to look for a 3 by 3 by 1/4 angle. Here we go. I'm going to add that item, accept it, and then I am going to see that the quantity required is in linear feet. So I am going to go back and check. I have 264 linear feet, so I will enter here in the quantity 264. When I enter that information, now I can see that this has a material cost of $12.59 per pound, and the software is converting already the cost per pound to cost per linear feet. So these 264 linear feet will have a weight of 1,478, and I see that is the total cost measured by length. So we have 264 linear feet at $1,259 per linear feet. We get $3,325, and we can see that there is no other value in here besides material. So this is accounting only for the angles and not the installation, not the bolts. If we want to export these to Excel, we'll go Sheet, Excel, and then it's going to create a temporary file with the information that we just entered. So I am going to copy these two rows, the header and the item, and I am going to paste that information into my Excel estimate. I'm going to create a new tab, okay, and in that new tab I am going to paste the information that I got from WinNest. So I see that I have this is the CSI code, angles 3 by 3 by 1 quarter, 264 linear feet. This is material price, material per unit. Material unit is in pounds, so there is a conversion factor. This will be the quantity in pounds, material price for a total value. So if we see this, all the values are numbers. There is no formulas in these values because I copy and paste that from WinNest. So what I would like to do is first to link the quantity takeoff to the quantity takeoff I have in on-screen takeoff. So I enter an equal sign, go to the on-screen takeoff data, and select the length for L1, which is this 3 by 3 by a quarter. So now this value is linked to the on-screen takeoff data that I've imported before. Then I want to also calculate the total cost uh, using a formula. So we have here the total cost is going to be the cost per unit multiplied by the unit of measure that we have. So that will be the 264 linear feet. So now this amount is in dollars, and it's related to the multiplication of the linear feet times the cost per linear foot. If we want to calculate the total for materials here, we can also do that as an equal the quantity that we have taken off multiplied by the price, the unit price. So we have $3,323.76 for materials. I would like to rename this tab to metals, so I know that I can keep track of the metals over here. And if I would like, I can add a note here, and then in that note I would say cost from WinNest. So I know that this cost came from the WinNest software. Using this code I can easily find that cost again. So now that I am done, I am going to save my Excel file. I'm going to save my cost estimate. I close that file. Okay, I close the temporary file that I don't need. Minimize WinNest. Close on-screen takeoff. We can find in internet information about the angles. So I found this information where we have the angle. We see that the dimension D and WB are the first letter, the first number in the L, the second number on the L, and then the thickness of this L is the third number. So L 3 by 3 by a quarter, it's an L that has 3 inches this direction, 3 inches in this direction, and the thickness of that angle is 1/4 of an inch. So we find that we have here the pounds per linear feet. So we will be able to calculate how much this L will weigh. I can use the calculations tab to convert the linear feet that we just measured to weight. So I'm going to create a metal uh, line here. I'm going to identify that with a different color so I know what we're doing. And I'm going to have the length measured in feet. I am going to have the weight per linear feet. That's going to be in pounds per linear feet. And I'm going to have the total weight in pounds. So for I may want to have also a description. So I'm going to add a description here for an L 3 by 3 by 1/4. We have the length in linear feet is going to be equal to the value that we measured in on-screen takeoff, which is this 264. The weight per linear feet is going to be the value that we found from the internet. In this case, it's 4.9. So I have 4.9 pounds per linear feet. And then the total weight is going to be equal to the multiplication of the length times the weight per linear feet. So we have 1,293 pounds. I can format this with a comma, and then that will present the number in a nice format. Okay, so now I have the material total calculated. I have my on-screen takeoff data. I have the calculations here, and I am ready to proceed with the submission of this work. But before I do that, I want to go to my Word document and add some notes about the roof steel frame. So I can say L 3 by 3 by 1/4 estimated just materials using Witness for the angle. Need to add labor, cost, and bolts. So we can work on that at another time. I am going to save my files, and now I'm going to get ready to submit these files as homework. So I save my files. I have to close on-screen takeoff, otherwise it will not save the information. So now I will go to the Blackboard where we have our assignments. I'm going to go to our home page, and I want to retrieve that on-screen takeoff database. To do that, I will go to the content and then course project. So in course project, I have this remote access server that will allow me to get information from my H drive. This asks for the username and the password. I log in, and then it will give me the full directories that I have access to. So I click on my H drive, I look for the 4612 database directory, and it contains the database that I want to use for my homework. Notice that there is a lock over here, LDB. That's a log file. So it seems like on-screen takeoff, when it closed, it did not erase that log file. So I'm going to choose just the database, the MDB file, and then I can proceed to either download or email that to myself, save it in a place where I can find it, and use it to submit that as a homework. So in this case, I am saving that in my computer so I can use it later on. I can open this folder, and then I see here is my database. Okay, it's under C document setting for my documents downloads. So now I know where can I find it to submit my homework. I go to the assignments. I look for the link to submit the homework, and then I'm going to make a note here. Please see attached files, browse my computer, and then I am going to get the first file, which is in the downloads directory for JMDB. Now I am going to add the other files. So I have saved on my desktop the Word document and the Excel file. So I will attach those two files, and now I can submit my work. So it will review, it will tell me that I have submitted these three files, and then it needs to be graded. That's all you have to do to work remotely with on-screen takeoff and Citrix.